In this video, we'll be looking at measures of spread for datasets of numerical data. So having a lot of data can be really good because it means we know a fair bit about the phenomenon or situation that we're investigating. But the more data we have, the harder it is to see what it all means. And so what we end up doing is summarising the data. Now, a couple of ways that we summarise data are to find what we call a measure of centre, and that's usually a single number that sort of gives us an idea of roughly where the data sits out of all numbers. We then also look at summarising the data with measures of spread. And measures of spread tell us, given that measure of centre, how far away are the data sitting? So are they all clumped around the measure of centre, or are they spread out quite a distance around the measure of centre? So three of those measures of spread that we can look at are the range, the interquartile range, and the standard deviation. The range is just the difference between the maximum and minimum data values, and it's probably the easiest one to figure out. The interquartile range is the difference between what we call the first and the third quartiles, and we'll take a look at what that is later. The standard deviation you can think of as like the average amount by which data values differ from the mean, where the mean is just the average of that data set. Let's take a look at an example for each of these measures of spread. In this first example, we're looking for what the range is for the data set 3, 5, 8, 9, and so on, all the way through to 8, 7, and 10. Recall that the range is just the difference between the maximum and minimum data values in our data set. So if we take a look at the data that we have, the maximum value in the list is, taking a look across, 3, 5, 8, 9, 11 looks quite large, and no other number is bigger than that, so our maximum value is 11. The minimum value, we've got a small one to start off with, 3, and if we look through the data set, no other number is smaller than that, so we'll say that our minimum value is 3. Then, the range, by definition, is that maximum value, take away the minimum value, which is 11 minus 3, or 8. In other words, our data set at the top of the example varies across a range of 8. If we were to look at our data on the number line, the minimum is 3, the maximum is 11, with a range of 8, and the median, if you were to go through and order the data set and find that at the 8th position, or 8th observation, you'd find that that is equal to 8. In this example, we're going to determine the interquartile range of the data set. The interquartile range is defined to be the difference between the third quartile and the first quartile. By definition, the first quartile is a value which has a quarter of the data below it, and the third quartile has 3/4 of the data below it. Visually, if we know the median of the data set, then the first quartile is just the median of the data which sits below the median. On the other hand, the third quartile is the median of the data which sits above the median. If we order the data in this example, we have 1, 2, 3, 7, 9, 12, and 19. This leaves us with a median of 7, a first quartile being the median of the data below the 7, which is 2, and a third quartile being the median of the data above the 7, which is 12. So we have Q1 equals 2, and Q3 is equal to 12. We can then go ahead and calculate the interquartile range as Q3 minus Q1, which is 12 minus 2, or 10. In this final example, we're asked to find the standard deviation for this small data set. In this example, I'm going to assume that this is the population of the data. In other words, it's not just some sample taken. The formula for the standard deviation differs very slightly whether we're looking at a population or a sample, so it's important to understand at the outset which we're going to use. Again, I'm going to use the formula for a population of data. So if we assume that the data that we have is the entire population of data, then the standard deviation is given by the square root of the sum of the differences between each data value, xi, and the mean, x bar, all squared, divided by the number of observations that we have. For a data set basically any larger than the one we have in this example, the calculations required for the standard deviation become quite tedious and time consuming. So normally we'd go to some sort of computational solution like a spreadsheet or specific statistical software. In this case, I'll go through by showing this by hand. The first thing that we'd need to calculate is the mean, x bar I've denoted it in this example. Now if you want to look at this measure of centre, check out my other video on measures of centre where I show you how to calculate this mean. But for now, let's just take it that x bar is equal to 54 on 7, or approximately 7.7. The next thing we need to do is this part inside the summation. We need to figure out the difference between each data value, 7, 14, 2, and so on, and the mean that we've just calculated, 7.7. Then we need to square that. Then we need to sum up all of those values before finally dividing by n and taking the square root of the result. But first, to figure out each of these little pieces that go on the inside here, I'm going to form a table which will show us how to calculate that for each data value. So I've created that table, and you can see in the left column I have the xi's, the data values, 7, 14, 2, and so on, from the data set in the question. Then I have two more columns. The first one is going to be those data values minus the mean, x bar, and then the next one will be the data value minus the mean, all squared. So let's take a look at one first of all. For the first data value of 7 take away the mean, 7.7, will be minus 0.7. If I square that value, I get approximately 0.5. For the next data value, 14, if I subtract the mean, 14 minus 7.7 is going to give me 6.3. If I square that, I get approximately 39.5. I'm going to pause for a second and then fill in the rest of these values. If you want to test yourself, try to do the next few rows by yourself. So there we go. We have the rest of the data values minus the mean, and then the square of the data values minus the mean. Returning to our formula for the standard deviation, on the top of the fraction, I need the sum of the xi minus x bars all squared. In other words, the sum of all the values in this column on the right. Adding those values, we're going to get about 139.4. The number of observations, n, is equal to 7. So we're now finding the square root of 139.4 over 7. With our calculator, that's going to be approximately 4.5. So the standard deviation for this data set is approximately 4.5. So in this video, we've taken a look at three measures of spread: the range, the interquartile range, and the standard deviation, which tell us a bit of information about how far the data is spread around a certain measure of centre.